we're ready to continue our review for the lecture Unit 3 exam. And so now we want to review lesson number 9 on crags, cracks, and crumples, geological structures, and mountain building. So this is going to be chapter 9 out of your textbook. And the first thing you need to know is, what is a stress? So stress is going to be when you apply a force to an area. So we did an experiment where you took the pointy end of your pencil and you applied a force to your finger. But the area on the tip was small. And if you take the formula there is stress is force divided by area. So if the area gets small, then the stress gets big. And so it hurts your finger more when you do that. Now if you take the rubber end of your pencil and you push against your finger, the area of the rubber end is larger. So this time if you're dividing by a large number, what comes out is a small number. So it doesn't apply as much stress to your finger. You're applying the same amount of force, but because the area of contact is either large or small, that's affecting the stress. So there are two different kinds of stress. You have confining stress, which means that the force is the same everywhere. So if you have an object and the force pushing up on it is the same as the force pushing down on it, and then from the side and from the side, if all of those forces are the same, then that's called confining stress. Another name for that is pressure. So the deeper a rock is under the ground, the greater the pressure is that's acting on it. Now if, however, the forces are different from a certain direction, then it's a differential stress. So there is going to be a net force that is coming from a certain direction. So what can stresses do to rocks? So it could make the rock slide sideways. It could make the rock tilt or rotate. We found in our lesson on earthquakes that it can make the rock break. So that's a rupture. Well, today, or in this lesson, we want to talk about deforming the rock, bending the rock, not breaking it. So breaking the rock goes with earthquakes, and now when we're deforming the rock, we're changing the shape of the rock. That's going to be caused by strain. So what is a strain? So strain is related to how much does the shape of the object change. It's the original, or the change in the dimension of the object divided by its original dimensions. So if you have a rock that originally was this big, okay, now you squeeze it and now it's this big. So the original length would be L sub 0, then you change it by this amount over here. So that's the change in the dimension. So you can actually compute the amount of strain. Now you're not going to have to do that on the exam, but that's where you can actually calculate the strain on an object. It's how much does its shape change. So what are some different types of strain? So you've got to know these words, so that you're going to have compression, and then you're going to have tension, and then you're going to have shear. So those are the three different types of strain. So let's first talk about compression. So that if the forces are being applied like this, it's going to take the rock and it's going to squeeze it. So that's going to be compression. You should know what kind of plate boundary would go with that. So what would cause forces to act on something like that? So we said that there was divergent plate boundaries, convergent plate boundaries, and then transform plate boundaries. So which is the one that goes with this? I'll let you go back in your notes and figure that out. Okay, then you're going to have a situation where rocks are going to be pulled apart like this. So that's going to be tension. So this one was compression, this one's tension, and then there's a particular plate boundary where the rocks are being pulled apart. You should know that for the exam. Okay, then you've got situations where one rock might be going this way and another rock might be going this way, and then that's going to be shear. And that, again, is going to be associated with a particular kind of plate boundary. So what determines how rocks are going to deform? So we said that a rock could bend, a rock could break, and then a rock could be permanently deformed. So in the case of taking a rock and bending it, if you release the stress on it, it returns back to its original form. If you put too much force on it, it's going to break. Sometimes, though, when you release the force on it, it doesn't return back to its original shape. And we say that it's behaving ductile when it does that. It's going to be behaving brittle when it first it's going to bend and then it's going to break. If, on the other hand, it bends and then it doesn't return back to its original shape, that's going to be ductile. So what's going to determine whether it does this or not? So one is going to be the amount of stress. So if you take a rock and you apply a stress to it, a small stress, it's going to bend, but if you release that stress, it goes back to its original shape. On the other hand, let's say you apply a lot of stress to it. Well, then it could break, or depending on the temperature, it may not break, but it doesn't return back to its original shape. Depends on the amount of pressure. So the greater the amount of pressure, the less likely it is going to be to break, because what's going to happen is all of that pressure is going to tend to hold the rock together. It's going to depend on the type of rock. So if you apply the same stress to limestone, it's going to break easier than if you apply that stress to granite. Okay, it depends on the amount of fluids in the rock. So that rocks that have lots of fluid in them tend to melt easier, and so that's going to mean they tend to be more ductile than they are going to be brittle. Then temperature. So at low temperatures, rocks tend to break. At high temperatures, they tend to flow. They tend to be ductile. And then it depends on time. So that if you have a rock, so let's say that it's a rock like this, and then you take another rock and you just put it on top of it, like that, then that's not enough of a stress to immediately bend the rock. But given enough time, what's going to happen is that rock is going to start to bend because of that additional stress that you're putting on top of it. So sometimes it takes a long amount of time to be able to notice that anything is happening. All right, let's take a break, and when we come back, we're going to talk about the different kinds of structures that stresses and strains produce.